3 power 3 in base system 10. In base system 3, it is 1 followed by 3 zeros. Write down this point. Number of trailing zeros. Number of trailing zeros in base system K. Number of trailing zeros in base system K. It is the highest power of K. It is the highest power of K. Very, very important point. Very, very important point. The number of zeros in base system K, it is 3. This is the highest power of 3 in base system 10. Highest power of K in base system 10. In base system 10. Suppose if I take a number which is in non-decimal, I convert into, if I take a number which is in decimal, convert it into non-decimal. Number of zeros at the end is nothing but the power of that base. Power of that base. 3 square. So number of zeros at the end will be 2. Now, the question is, find the number of trailing zeros. 100 factorial. 100 factorial in base system 10 is converted into base system 6. If 3 is converted into base system 3, how many zeros are there? 1 0. So this question is as equivalent to writing highest power of 6 in 100 factorial. Highest power of 6 in 100 factorial. I hope the concept it is clear. 100 factorial is converted in base system 6. Very, very interesting question, sir. Most of the students think that it is a difficult question, but actually it's an easy question. 100 factorial is converted in base system 6. 3 in base system 10. If I convert into base system 3, it is 1 0. 3 square in base system 10. If I convert into base system 3, it is 1 0. 100 factorial in a base system 10. If I convert into base system 6, the number of zeros at the end. Number of trailing zeros. Number of trailing zeros. Number of zeros at the end. Number of zeros at the end is the power of 3. What is the 3? Base. Number of zeros at the end is the power of 3. What is the 3? Base. Number of trailing zeros is the power of highest power of that base. Highest power of 6 in 100 factorial. Highest power of 6 in 100 factorial. 6 can be written as 2 into 3. 100 factorial. It is 2 power 97 into 3 power 48 into K1. So this will be 2 into 3 power 48 into 2 power 49 into K1. Answer will be 48. Very, very good question. He is just confusing you by giving you this question. This question is actually nothing but highest power of 6 in 100 factorial. Highest power of 6 in 100 factorial. Suppose if the question is 150 factorial is converted in base system 7. 150 factorial is converted in base system 7. It is nothing but highest power of 7 in 100 factorial. Highest power of 7 in 100 factorial. Answer for this question will be 24. Answer for this question will be 24. I hope the idea it is clear. Very, very interesting question, sir. Number of zeros at the end in base system K is the highest power of K. Number of zeros at the end in base system K is the highest power of K. 150 factorial, if I convert into base 7, zeros at the end is equivalent to the highest power of 7 in 100 factorial. I hope the idea it is clear. Next one. Oh, easily you can solve. Now see here. Concept. Number of trailing zeros. Number of trailing zeros. It is the highest power of 10. Highest power of 10. 10 it is 2 into 5. 2 into 5. When you are writing the number, 2's will come more than 5. So answer we took it as n is greater than 4x. N is greater than 4x. Am I right? The same thing here. N factorial ends with 20 zeros in base 21. In base system 10, I took 2 and 5. In base system 2, 1, it is 3 into 7. So 3's are more compared to be 7. So the relationship is n is greater than 6x. N is greater than 6x. So n is greater than highest power, highest prime power minus 1 into x. Highest prime power minus 1 into x, where base k can be written as P1, P2 and P3. Highest prime power will be the maximum of P1, P2, P3. Very, very interesting concept, sir. Highest prime power. Suppose in base system 10, 10 is 2 into 5. So n is greater than 4x. Because power of 5 will be less than the power of 2. In a base system 21, it is 3 into 7. Power of 7 will be less than power of 7. Same thing you will do. N by 5 square we did. N by 7, n by 7 square we will do. Very, very easy. This is a mock question which I created some years before. N factorial ends with 20 zeros in base 21. K is 21, which is 3 into 7. What is the maximum value of 3 and 7? 7. So n is greater than 6x. N is greater than 120. What is the multiple of 5? I took it because highest is 5. What is the multiple of 7 greater than 120? 126. 7 18s are, 7 2s are. 18 plus 2, 20. So 126 2. Till the next one number less than the multiple of 10. How many values 7 will take? This is a very interesting question, sir. So, can I correlate the question in base system 10 to base system 21? In a base system 10, the number of trailing zeros is given by the highest power of 10. 10 is 2 into 5. 10 is 2 into 5. So based on 5, I got the relationship 4x. In 21, it is 3 into 7. How you got n greater than 7? 6x x equivalent to n by 7 plus n by 7 square, n by 7 cube, and so on. And so on. So x is less than n by 7 common, same thing. So in a base system 21, what is the relationship? N is greater than 6x. N is greater than 6x. Now see here, in a base system 10, n factorial ends with x zeros. N factorial ends with x zeros. So 10 is 2 into 5. So n is greater than 4x. This is the relationship. If it is, for example, 21 is 3 into 7. N is greater than 6x. N is greater than 6x. In a base system 6 is 2 into 3. 5 became 4. 7 became 6. N is greater than 2x. N is greater than 2x. I hope the idea it is clear. These are some very, very interesting questions on base system. Now, n factorial ends with x zeros, n greater than 4x. Some other base, how to solve, how to find out the number of trailing zeros. All these questions, we discussed this. Trailing zeros, session